Hi guys, today we're looking at note set 5, and really we're just putting arithmetic and geometric sequences together, so I'm working more with both of those different types of sequences. So we're starting off with some word problems, and I will tell you that problem 1 is pretty straightforward, but 2, oops, I numbered wrong, 2 and 4, they're going to be a little tricky, so we're going to talk about those some. So in the first question here, we have a skydiver, and he falls 16 feet in second 1, 48 feet in second 2, and 80 feet in second 3. And we want to know how many feet will she fall in the 10th second. So we can tell that we are going to find a sub 10. So we do have to decide what kind of sequence this is, and as you look at it, you can tell that it's arithmetic, and our arithmetic common difference is 32. Remember, arithmetic sequences are modeled with linear functions, so I need to write the equation of a line. I know I have the point 116, so a sub n minus 16 will equal 32 times n minus 1. Since I'm finding a sub n, every time a sub 10, every time I see an n, I'm just going to plug 10 in. So I get a sub 10 minus 16 equals 32 times n minus 1, or 10 minus 1. And so I get a sub 10 equals 304 feet. And I know you guys can do the arithmetic here. I do want you to notice one thing. I was sure to put units here. Units are important anytime you see an application problem. All right, let's look at this one. It's kind of tricky. A vacuum pump removes 1/10 of the air from a space capsule on each stroke of its piston. What percent of air remains after 4 strokes? So here's what's a little tricky. You're removing 1/10, but it's asking you how much remains. So to start with, how much do we actually have? Well, we have 100%. I mean, that's initially, it's full, so it has 100%. And so after the first stroke of the piston, 1/10 of that is gone. So how much are we left with then? We'll be left with 90%. Okay. So then again, remember, you're losing 1/10 of that 90%. What am I multiplying by to get how much will be left now? Well, if I take 90% and multiply it by 0.9, isn't that how much is remaining? I get 81%. So this is geometric, where R is 0.9, and of course you can write that as 9/10 if you want to. And actually, if this were me, I would just write this the rest of the way out, because I'm only looking for what happens after 4 strokes. Now here's the thing to remember. The first term here, 100%, did not count as a stroke. That's how much we had in it to begin with. So this is the first, second, third, fourth. This is the one you need to try to find. But if it were me, I would just take my calculator and I would keep going. So I'm going to multiply 81% by 0.9. And I'm going to get 72.9% remains. Multiply that by 0.9, because every time you're losing, or your 90% is remaining, excuse me, and we get 65.61%. So our answer would be that 65.61% of the air remains. Number 4 is kind of similar. So we see that we have a business that's worth $40,000. The equipment depreciates at 20%. Now, What does depreciate mean? It means that's how much value it's losing. The question says, what will the value of the equipment be at the end of the 6 years? So let's kind of organize our thoughts here. First off, since we're talking percentages, we are going to be multiplying, so this is a geometric. But if it's depreciating 20% per year, what's its value? What value is left over? Well, that would be 80% or 0.80. So this is another one that's a little tricky in that 40% is the initial amount. And at the end of that first year, I would need to take 40,000 times 0.8. This is the end of the first year. Okay. If I wanted to find out about the second year, I would take 32,000 and times it by 0.8. And I do have my calculator here, by the way, working on those. So this can be one, I mean, you could go out to the 6th year, that's perfectly fine, there's nothing wrong with that. Or you could write the explicit formula, and just so it doesn't throw me off too much, I'm going to use that the first point is 32,000. Okay, I can work this 2 different ways here. So I'm going to write this as A sub n equals 32,000 times 0.8 to the n minus 1. And it says what happens in year 6, so I'm looking for A sub 6 equals 32,000 times 0.8 to the 6 minus 1. Now just a side note, you could use 40,000, but your exponent would not be n minus 1, it would just be n, because this is actually year 0. And when you type that in your calculator, you should get 10,485. I'm going to round to 2 decimal places, 0.76. All right, let's keep going. So I see this is arithmetic, and I have a point, and I have the slope. And so those 2 things allow me to plug this into point-slope form. It asked me to find A1. So I'm just going to plug 1 in. So A sub 1 will equal 21 plus 3/2 times negative 25. And that's going to equal negative 13.5. Let's look at the next one. This time I've got a point. Ooh, kind of got another point. And I know the rate of change, the slope, the common difference. And by the way, guys, there's a whole bunch of ways you can work this particular problem. Let's use the fact that an arithmetic sequence is a line, and we know how to find slope. We know the slope is 3. And we find slope by taking change in y's over change in x's. Can I solve for n this way? Well, I want to get rid of this fraction, so I'm going to go ahead and multiply by n minus 1 on both sides, so I'll get 3 times n minus 1 equals 726. Oh, wait, I copied the problem wrong. That should be a 7, that should be a 7. So this should be a 9. I'm now going to take 729 and divide it by 3. I'll multiply it by 1/3, so I get n minus 1 equals 243. So n is 244. That's just one way to work this problem, by the way. I could also use point slope form. All right, let's do number 8, since it's right below where we are. I know I'm skipping around, that's okay. So I see that this is geometric. I know that because it gives me an R, and the instructions say that. I have a point, and from that point, I can write my explicit formula. I know A of n will equal negative 1,024 times negative 1/2 to the n minus 8. And it asks me to find A1. I can just plug that straight in. And when I do, I end up getting 131,072. All right, last one. All right, I have my point. I have a common ratio, so I know A sub n will equal negative 2 times negative 2 to the n minus 1. Again, I use the 0.1, negative 2 here. I now know A sub n, so I know A sub n is 256. I'm trying to solve for n, and notice where that is. It's in the exponent, so we're going to talk about that a little bit. First thing I'm going to do is I'm going to get this exponential part by itself. So I'm going to divide by negative 2. So 256 divided by negative 2 is negative 128. Okay, so the question becomes, how can I solve this? Well, I'm really trying to figure out what can I take negative 2 and raise it to that would give me a negative 128. I mean, if you think about it, that's what I'm doing. By the way, you don't know how to solve this equation yet. You use it algebraically, a method called logarithms. We'll learn about that, just not right now. So as I'm looking at this, I'm thinking about negative 128. Is it possible to write it as negative 2 to the sum power? And if you think about that for just a moment, I hope you get that it's to the 7th. So I know negative 2 to the 7th is negative 128. So doesn't 7 have to be the value of n minus 1? So n has to be 8. And we could go back and test that, plug 8 in here. So I get negative 2 to the 8 minus 1 is negative 2 to the 7th, and that is negative 128. Thanks.